What's going on, everybody? This is Mr. Diamond again, here to begin our Section 3 notes for Chapter 7, I think it's Chapter 7. This is going to be some advanced stoichiometry. Now, there's going to be a lot of background information today, so much so that I am going to probably separate the example problem in this into two videos, just so I can go and take a water break and stuff like that in between it. But we're going to be talking about advanced stoichiometry. I tried to edit a picture of that SpongeBob, this isn't just darkness. This is advanced darkness, but with advanced stoichiometry, but I didn't have time to get that to actually work out. So before we do that, though, let's go back and talk about chemical equations again, just to make sure that we're feeling good about it. Because if you watch the Minecraft video, you've hopefully realized that we're going to be making connections now to full-on equations that have more than just one piece involved. And to do that, we're going to need chemical equations. So go ahead and pause the video and try to turn this from a name of these two chemical substances and predict what reaction would form from it. So I'll give you a couple of seconds. Okay, let's talk through the process. So sodium chloride, sodium is Na, chlorine is Cl. Sodium has a +1 charge, chlorine has a -1 charge. They'll just cross, you'll get NaCl. Aluminum sulfate, aluminum is Al, it has a 3+ charge. Sulfate is SO4 with a 2- charge. Cross those, you get Al2, SO4, 3. And then because it's a double replacement, because this is a compound and this is a compound, we're just going to swap our first pieces. So you'd get aluminum chloride and sodium sulfate. Then you just cross your charges with those, and you should get this. NaCl plus Al2SO4 3 gives you Na2SO4 plus AlCl3. You don't need to use activity series or anything like that, because this is not a single replacement problem. Now that you have that, though, there is one other step that we have to do. It's the thing that I always, try to trick you into saying that, we're done with the problem and then you have to tell me what we do next, and that is balancing. So to balance it, we're going to put a 6 out front, and it's going to be 6 NaCl plus 1 Al2SO4 3, and then we'll need a 3 and a 2 on the other side. 3 Na2SO4, and then 2 AlCl3. Just to double check, we have 6 Nas, 3 times 2 is 6 Nas, 6 Cls, 2 times 3 is 6 Cls, 2 Als, 2 Als, 3 SO4s, 3 SO4s. Okay, so we got it balanced. Now we're gonna come back to this problem later, but first we're gonna shift gears again, and we're gonna talk about something that hopefully at least will make it a little more clear why I did that Minecraft video. Let's think about what our equation was actually saying. When we balanced the equation, we were just focused on making sure that we obey the law of conservation of matter. We made sure that there were no atoms being created or destroyed. That's why we needed this 6 here. This 6 was to tell us that you got 6 Nas over on this side, and we've got 3 times 2, which is 6 Nas over on this side. We can't break science. We can't break the rules, so we have to have the law of conservation of matter satisfied. To do that, we just put those coefficients out front, and they modified how many elements are involved. But you actually did more than just that. Those numbers out front actually give you a ratio. This is a ratio here. You've got 6 NaCls, 1 Al2SO4 3 Na2SO4s, and 2 AlCl3s. These are ratios that can compare to each other. And this is why we get to our Minecraft example. This should hopefully help you get the concept a little bit better. So let's say that I have 24 diamonds, and I have the question, how many diamond swords can I make? How many sticks do I need to do that? How many pieces of wood planks do I need to get that many sticks with this little slash that I forgot to delete? And how many logs do I need to get that many planks? And this is what I was kind of talking about in that Minecraft video. So let me switch to my hand cam. So our question here is we want to know how many diamond swords and then sticks we need, planks we need, and logs we need. So let's start. We've got 24 diamonds. Oh, I apologize, guys. We've got 24 diamonds. You don't have to obviously do this problem, but 2 diamonds. We're not making axes this time. 2 diamonds are needed for 1 sword. So for first example, how many diamond swords could we get? Well, 24 divided by 2 would be 12. We make 12 swords. Next, how many sticks do we need? Well, we can convert. We know that each sword, one sword, requires one stick. So how many sticks do we need? Well, it would have to be 12, because this would convert diamonds to swords, swords to sticks. Okay, what about planks? Well, 2 planks... Sorry, wrote it on the wrong side. 2 planks give us 4 sticks. So 24 divided by 2 is 12, times 2 is 24, divided by 4 is 6, so we'll need 6 planks. And then finally logs. So 1 log gives us 4 planks. So 6 divided by 4 would be 1.5. So we need 1.5 logs. So basically we can go punch down 2 trees or 2 logs from the tree, and we should have enough to make all 12 of our diamond swords, if for some reason that's something that we wanted to do. Now, switching back to our notes here, let's break down what we did in that example problem. We determined the reaction, or in this case, the recipe that we were working with, and then we used that as a conversion factor to convert it from one substance or ingredient to another. A sword is made out of 2 diamonds, so we could convert between diamonds and swords. This is the exact process that we're going to be doing, but instead of doing Minecraft recipes, unfortunately, we are going to be using chemical equations, and we'll be converting from one element into another. So let's go back to this reaction from earlier. This reaction is telling you a ratio. For every 6 NaCl's you put in, you will need 1 Al2SO43, and you will get 3 Na2SO4s, and you'll get 2 AlCl3s. These numbers can create what are actually called mole-to-mole ratios. This isn't just a number. This is how many moles you can use of each of these numbers or each of these formulas to compare to one another. So this piece right here, this is the piece that makes stoichiometry incredibly useful. This is why we aren't just calculating, okay, well, how many like individual atoms do you have? This allows us to make predictions or to figure out how much of something we need to get a reaction to happen. And it kind of opens up a whole new world of possibilities for us, chemically speaking, now that we can use these ratios to convert between moles of one thing and moles of another thing. Easiest way to learn is going to be through a practice problem. So this is going to be the practice problem that we're going to do. We'll go ahead and work that out in a later video. Let me double check and make sure there's nothing after this that I want to talk about. Okay, yeah, so in that problem, we're going to be converting between one reactant and another, but you can convert between any piece in the problem. If you pick a product, you can just calculate the yield that you'll get. We're going to discuss that a little bit later on, though. This is kind of going to be the flow chart that you're going to be using, or that you can kind of use to help. This is what I wanted to make sure I got to, so you could write this down and use it for helping you work through that example problem. So if you have one sample, so in this case, A is going to be one of our compounds or element that we're working with, and then B is going to be the other compound or the other substance that we're working with. You can go from any piece over here to any piece over here in a chemical reaction. You could figure out particles of A into how many grams of B you have. Or if you have mass of how much of something A in a reaction you have, you can figure out exactly how many particles of that thing you'll need. Or you can stop in the middle and you can go to any of the moles of any of the pieces. Sorry, I was jumping ahead. So this flowchart is going to be really important. I would highly recommend that you write it down in your notes and have it on a little piece of paper that you can look back to. We're going to go ahead and switch over to, you'll need to watch the other video that has me actually working out the example problem. If you have questions, please let me know. Like I said, this is going to be bringing a lot together and is going to be super important. So definitely make sure you email me questions. I hope to see/hear from you soon. Have a great rest of your day, everybody.